Greetings of the day. Today we shall see about 1,2 and 1,4 addition in 1,3 butadiene. So we have already seen what are dienes, types of dienes, butadiene structure and different methods of preparation of butadiene. Here butadiene 1,3 butadiene is an excellent example for conjugated dienes. See here the structure of 1,3 butadiene. Between C1 and C2, there is a double bond. And between C2 and C3, there is a single bond. Between C3 and C4, there is a double bond. So, there are alternate single and double bonds. So, it's an excellent example for conjugated dienes. So, when this 1,3-butadiene undergoes electrophilic addition, it will give two different products. Okay, one it is controlled by kinetic thing and another by thermodynamic thing. So we shall see what is really happening there. So we shall consider one reaction. Electrophilic addition of HBr. So we can take any one electrophile. Okay, so HBr or HCl. Here we shall take the example of electrophilic addition of HBr to 1,3 butadiene. So what will happen? Our HBr, it will ionize. There is difference in the electronegativity. So bromine, it will take up the electron density towards itself. So it will attain one negative charge, and our our hydrogen will have some positive charge. So H plus and Br minus. Likewise, our HBr will exist. Now, as a first step, there will be protonation. The H plus ion formed from HBr, our electrophile, it will attack the C1 carbon. Okay, so in 1,3 butadiene, 1, C1, C2, C3 and C4 carbon. C1 and C3, they have got the double bonds. So our H plus ion now will go and attack the C1 carbon. So what will happen is there will be a formation of carbocation. In presence of any electrophile, the double bond, what will happen? The pi electron total shift of the pi electron will take place, either of the carbon, and this is governed by Markovnikov's rule. So when hydrogen halide is added to an unsymmetrical alkene, our acidic hydrogen will be adding to the carbon which has got more number of hydrogen atoms. This is Markovnikov's rule. Here based on this Markovnikov's rule, here see this C1 carbon has got 2 hydrogen atoms and this C2 has got only 1. So our H plus ion will go and add upon to this C1 carbon. So it becomes CH3. Okay. So CH3. Double bond is broken and the CH2 become CH3 and this CH, this carbon becomes a carbocation. Again, it is a stable carbocation. Markovnikov rule plays here. Okay. So we have formed one allylic carbocation. This allylic carbocation, it can undergo resonance. See here, this is our allylic carbocation formed at the C2 position. The carbocation is there. It's a secondary carbocation. It is a stable carbocation. But here it is a carbocation. There is a double bond between C3 and C4. So they can undergo resonating, that is resonating structures can be written, that is electron displacement may happen, right? So here in this structure you can see the structure here. Because of the positive charge here, the pi electron from C3 will flow towards the C2 carbon. So what happens here? The double bond will be shifted between C2 and C3 now. So this C4, this carbon will be losing the pi electron. So it will now become a carbocation. So by resonance, this allylic carbon can be written in these two different ways. So in the first structure, we have got the carbocation at position 2. And in the second structure, we have got the carbocation at position 4. Yes. So this is the reason why we got two products. Because of this electrophilic addition, we can obtain two products. We have seen that, no. So now Br minus will attack carbon 2. Yes, carbon 2, where we have got the positive charge. So first thing, hydrogen adds up to the C1, and now bromine adds up to the C2 carbon, so that the product is formed. This product formation is very fast, and this type of reaction, that is 1,2 addition, this is the name because the addition has taken place in C1 and C2 position. Okay. So this 1,2 addition always be favored by the low temperature. Okay. And it will be faster. So it is kinetic controlled one. Now come to the uh, addition, that is C4 addition. Here, see at C1 position, hydrogen is attached, and at the C4 position our bromine has got attached. So the product here formed is this, as shown here. So the double bond has got shift between C2 and C3, and this is a very stable thing when we compare to the previous one. And this structure, this product is favored at higher temperature, and because of addition taking place at C1 and C4, this addition we used to call as 1,4 addition. So only, that is because of kinetic control at low temperature, and with a very fast thing, we will be obtaining one product. And with the thermodynamic control at high temperature, reversible, most stable product will be obtained. So as a summary, when you got any this 1,3 butadiene, when it is added, when electrophilic substitute addition reaction take place at low temperature, 1,2 addition. See here, see 3 bromo, yes, 1 butene is our product here, and here 1 bromo, 2 butene. Butene is the product here. So thank you for watching.